Welcome back to the WBSA. We're very excited to have you here. Before we start and I introduce Michael, I have to extend Rebecca's apologies for not being here. As you can tell, I'm not Rebecca. Sorry if you were expecting the director, but for reasons that she couldn't control, she had to go to the UK. But she told me to welcome everyone, and that she's really sad she couldn't attend this week's Archaeologically seminar. I'm super excited to have Michael here for too many reasons. Actually, most of you might know Michael already. He was here, the assistant director before me, and I'm so happy he was here before me because he did everything right. He tidied so many things. He did a lot of work, good work in the museum, in our collection. He did a lot of tidying up in our systems and processes, and really got his hands on a lot of projects and helped bring them to completion or initiate certain projects. So I'm super excited for following up from Michael. And for those of you who don't know Michael very well, he finished his PhD in Cambridge, where he's again now as a Leverhulme postdoctoral fellow for the next 3 years. Yeah, okay. And Michael's expertise is networking. He studies networks between archaic and classical cities using GIS and quantitative analysis to better understand, help us better understand connections between cities, economic and political connections between cities. In fact, he almost has a book on it, which is to be published in a few months. The book is titled "Connecting Communities in Archaic Greece," and we are very looking forward to reading what Michael has to say about this. And Michael has his hands on a lot of projects, as I said, and a lot of excavations. He's working on the Palace of Nestor in Pylos, and he's now he has worked on Samos, and he's still working on Samos. And we will hear about Samos today, wrong title, material and landscape on archaic and classical Samos. And in fact, if you can't get enough of Michael, you can come back on Thursday in a workshop that we are co-hosting, which is titled "Mapping the Past, Plotting the Future: GIS in Archaeology, Maturity and Implementation," and where Michael is also presenting again some findings and some materials about Samos. But I will not keep you waiting for longer. The floor is all yours, Michael.
Thank you so much for the very warm introduction, Yorgo. It's great to see that the assistant directorship has been left in good hands, and also in the hands of a northerner, a fellow northerner. That's always nice. It's very nice to see you all here, to see lots of familiar faces, but then also to meet for the first time some of you who I've only met so far over email or over Zoom. As Yorgos pointed out, I was the coronavirus assistant director. There are many things from that whole period that I think we'd like to put in a box and leave. But I think one thing that the British School at Athens can be very proud of from that period is this seminar series, the Upper House seminar series, that kept going and provided such interesting and stimulating and rich academic content for so many of us throughout the lockdown period. So having sort of worked in the background, helping to run some of the tech for some of those seminars, it really is very nice to be here in person with you all this evening, and also with the British School at Athens diaspora who are joining us this evening in cyberspace. You're all very welcome, and it's great to see you. So my first question this evening is, why Samos? Samos is a medium, large-sized island in the East Aegean, administratively in the North Aegean region of Greece, and its easternmost point is a mere 2 kilometers across the Mykale Strait from the Anatolian mainland. During the Archaic and Classical periods that I will discuss this evening, which I'm roughly taking between the 7th into the 4th centuries BC, Samos first gained renown as a maritime superpower under the late 6th century tyrant Polykrates. Herodotus tells us that both through diplomatic relations and through state-sponsored piracy, Samos established strong overseas links, particularly with Egypt, and wealth and non-locally produced riches and raw materials flowed towards the island. Samos was famed for its navy. Reportedly, the Samians built the first trireme at the request of the Corinthians in the late 7th century BC. By the decisive Battle of Lada in 494 BC, Samos had 60 warships to contribute against the Persians, 60 warships that subsequently deserted the Allies, but 60 warships all the same. So to frame all of this in the language of connectivity for the terms of my presentation today, Samos of the historical record demonstrates strong off-island maritime networking from as early as the Archaic period. Unlike some of its other Ionian neighbors who were sacked by the Persians, Samos had some degree of freedom to maintain and develop some of its connections throughout subsequent eras. The Samians turned against the Persians before the Battle of Salamis, sending messages of support and intel directly to Themistocles. Samos remained generally loyal to Athens throughout the 5th century and held a position of special privilege in the Delian League. That is until 440 BC, when Samos had allied herself with Miletus over a territory dispute at Priena. Pericles and his forces besieged Samos, and in the manner of other revolting allies, Samos was forced to pay tribute to the Athenians, 1,300 talents, to be paid in installments of 50 talents per year. From a landscape and demography perspective, it's particularly interesting that the historians tell us a group of Samians were exiled and that some of the land on the island was parceled up for the Athenian colonists. Many of the ancient authors note Samos for the richness of the natural resources that it provided. From the author of the Homeric hymn to Apollo, who notes Samos for being well-watered, to Aeschylus extolling the island for its richness in olives, to Herodotus noting the supply of timber and stone on the island, perfect for the construction of warships, to Athenaeus describing vine-colored hills of the island. Samian manufactured amphoras and those of a South Ionian workshop, common with Miletus in the Meander Valley, are indicative of the production and export of wine and olive oil, both locally and supra-regionally from the Archaic period onwards. And equally strong is the reputation for the wine production from Samos's neighbor, 20 kilometers to the west on the island of Icaria. The iconography on some of the coinage from Samos provides yet another indicator that Samos concerned herself with the production and export of wine and other resources. On the reverse of this coin here, a bull, amphora, ear of wheat, and a peacock, reportedly peacocks at the sanctuary of Hera. And from the 6th century, at least, a distinct weight standard used only on Samos is indicative that the island played a role as an economic networker across with other archaic communities. Beyond antiquity, Samos was a producer and a node in international networks. Early modern travel accounts note the production of pitch, oil, onions, and honey from the island, and a number of the muscat wines and brandies that were popular in Northern Europe, particularly in the French markets. Today, the tradition of wine production and its international export on Samos is continuing, particularly notably from the Eos winery. Beyond these scattered references, though, the wider and landscape history of Samos is lesser understood. The archaeology of Samos has naturally gravitated towards its sanctuary of Hera, with over 100 years of very detailed and important work undertaken first by Greek colleagues and then by the DAI, some of it led under the direction of Professor Niemeyer, who joins us today. The discovery and publication of important structures and object groups across the Heraeon, from the prehistoric, archaic Roman, to the Kouros, to the gymnasium, to red figure pottery and the faience, has all brought much information on the diachronic history of the site to light. It may well be the case that we can use the history of this site to write the history of the whole island and its landscapes by measuring the prosperity of the sanctuary. But where else can we look? To verify this picture, we can look further across the island. Excellent work by the then 21st Effort of Antiquities, published in the Deltion volumes of the 1980s and 1990s, rescue archaeology taking place across the town of Pythagoreio. Reports from these areas are now, of course, online through the Archaeology in Greece online project. And thanks to the efforts of the French school and their Per se Chronica collaboration, and from our colleague Catherine Bourras, all of that information can be accessed on AG Online. New work continues to be undertaken across the island by the Effort of Antiquities of Samos and Icaria, who will bring to light a great deal of important and valuable data, for example, from the excavations of a new road linking Pythagoreio and Pyrgos. A new survey from Uranir Kukar and the Cyprus Institute will shed light on the hinterland of the Heraean, documenting in particular a prehistoric presence in the east part of the island. And through petrographic work, some undertaken by Sergios Menelaou of the BSNZO Fitch Laboratory, questions about how this area networked with other island communities in prehistoric periods will be answered. To address issues of landscape, particularly in the west part of the island, a relative terra incognito, and with a particular interest on the first millennium BC, in 2021, we launched a new 5-year research program investigating broadly defined the area between Mount Carvunus and Mount Kirkis in the periphery of modern-day Marithacampos in the southwest of the island and Karlovasi in the northwest of the island. My particular role on this project has been to design the survey methodology and to help produce and implement a paperless digital recording strategy. Our survey builds in many ways on the work conducted in the 1980s by Graham Shipley, who undertook extensive exploration across Samos. Shipley's catalogue of 21 sites across the 2 basins of Karlovasi and Marithacampos is an invaluable resource in orientating oneself towards sites of interest, drawing both on extensive field exploration and benefiting from the local knowledge of local connections that Graham made. This is also an important resource for documenting, in however cursory a fashion, the state of the archaeology of these places before more intense periods of development across the island of Samos, particularly around holiday destination areas on the coast. And I and the whole team would definitely like to thank Graham most warmly for his ongoing kindness and support of this project. Our principal method of exploration is intensive pedestrian field survey, with a view to documenting extensively evidence for diachronic activity across the landscape, to verifying and mapping the extent of points of interest first identified by Graham Shipley, to using material culture to consider possible activities, dates and functions of sites identified, thereby elucidating the position of Marithacampos and Karlovasi within island-wide and regional networks, and with an eye on issues of resource and export, as discussed above, to investigate how the archaeology of West Samos can tell us more about how this part of the island played a role in Aegean and Anatolian economic networks of the first millennium. Our field walking builds on methodology and a data model of the Panormus survey directed by Anja Slavish and Toby C. Wilkinson, the Panormus survey being our neighbours on the Milesian Peninsula just to the east. A predefined grid of 50 by 50 metre units is drawn pre-season over our survey area, and these areas constitute the units to be explored by field teams. Teams consist of 5 walkers spaced at 10 metre intervals. Surface ceramics are counted, and with all diagnostic pieces are collected for analysis. And at this point, I would like to thank again the Effort of Antiquities of Samos and Icaria, and the effort, Dr. Triantafylidis, for kind permissions to collect, store and study the finds, and for their role in facilitating our work. Walkers all note the ground visibility of their transect and record extensively all non-ceramic and ground features of interest. Team leaders take additional notes and photographs for each tract, including view sheds of key locations in the landscape and erosion and slope values of the tract. These data are recorded on tablets through a system called Kobo Collect, which records information offline and syncs to the main project cloud once the team return to base and become within reach of a Wi-Fi connection. I, along with colleagues Alexandra Kataverni and Anastasia Vasiliou, who have helped to design and implement this system, will be talking more about the technical aspects of this system back here in the BSA on Thursday, as Yorgos mentioned at the start. Our primary spatial unit of analysis in this project is the Walker line. We do not plot the raw number of ceramics counted by any walker in any tract, but we count a weighted ceramic value, which is calculated for each Walker line. To calculate the weighted value, we take the raw count and we adjust for tract visibility. And we also take into account a walker's own personal statistic. Some of us will see and count less, while others will include additional counts, perhaps tile counts or rock sherds in their count. So we adjust for this bias as well. Finally, we adjust for relative distribution of material across the whole study area. This metric is calculated separately for both on-site and off-site areas. And as you will see in just a moment, we have two very different scenarios arising from our survey area. In 2022, we covered 3 kilometers squared in the southwest basin of the island, covering 816 tracts. This includes areas marked unwalkable owing to sheer topography or inaccessibility from private property. We ran a transect from the modern settlement of Velinidia in the east of our area to Limnionas in the west, getting as close to the coastline as we could, but in many cases working behind the modern town of Campos. Much of our work was concentrated around Velinidia. This is a lowland area in the southwest basin of the island, in the shadow of Mount Kirkis. There is terracing and modern cultivation here, with ancient material eroding out of the terracing and accumulating in the lower basin. There was moderate human disturbance at Velinidia, particularly towards the south of the coast, where various houses have been built, and in the fields to the west, mainly comprising tile dumps. There was cultivation of olive trees across the higher slopes of Velinidia, and reeds starting from the beginning of an old river channel that extends west of Velinidia. High densities of material had been identified in extensive survey right from the coastline up to the north hilltops on the edges of the unwalkable area. And for this reason, our transect extended a little bit further in the north-south direction in Velinidia, as opposed to other places as we went along the coastline. So looking across the whole survey region, 15 areas of interest have been defined. These areas of interest, or AOIs, are designated qualitatively on the basis of Walker line relative density. In addition, we define AOIs in areas where, even though there is low overall ceramic count, there are large numbers of diagnostic ceramics counted or an unusual quality of diagnostic ceramic sherds collected. 6 of these AOIs come from Velinidia. Surface finds were particularly abundant in this area, constituting a large region of on-site density. Of 290 tracks walked, 19,950 pot sherds were counted, from which 1,461 diagnostic pieces were collected. This represents a collection rate of actually only 7%, where the average walker visibility was 37%. Note from this image to the location of AOIs that we're calling Vel 1, right at the top of the hill, and the large expanse of terraces that we call Vel 2. I'll elaborate further on these 2 areas in a short while. The second most productive area where we walked was located behind the town of Campos, in another shallow area of ploughed fields and olive cultivation. In this region, the chapel of Ios Ioannis stands on the highest point, under whose foundations a large scatter of well-preserved pottery radiates. Much of the pottery can be dated to the early Byzantine period, but there are significant positive indicators of material from the first millennium too, notably from the Hellenistic and Roman periods. Of 104 tracks walked here, 1,540 potsherds were counted, from which 325 diagnostic pieces were collected. The collection rate here was higher than at Velenithia, totaling 21%, while average visibility was lower at 26%. I'd now like to present some of the preliminary ceramic distribution patterns. And for this, I would like to thank Sabina Hui and Francesca Zandonai for their hard work and rapid turnaround studying the pottery, which has enabled us already to present some of these preliminary spatial patterns. Regarding Bronze Age ceramics, we have very few pieces. As you can see from the screen, very, very few pieces, but some positive indicators perhaps in the higher upland areas of the survey, coming from very coarse and medium cooking and storage wares. From Limnionas, we also have a piece of obsidian, possibly work chip stone, and congratulations to eagle-eyed team member Katerina Ayareki for being the one to find obsidian on the survey this year, the only one. Archaic material is spread between Ios Ioannis and Velenithia, with most of the pottery coming from the top of the hill at the AOI that we call Vel 1. I'll speak about Vel 1 shortly. The classical pattern looks very similar to the archaic pattern, both in terms of distribution, but is lower in absolute numbers. Both archaic and classical sherds come from predominantly transport amphoras as well. Hellenistic material is fairly elusive in our survey, but there were pieces found nearer the coast of Velenithia and over to the west at Limnionas, areas not represented by archaic and classical pottery. These areas continue to be abundant hotspots for the Roman pottery, while also the area immediately surrounding Ios Ioannis is particularly productive in this period. And Byzantine is our most represented pottery period across the entire survey area, turning up in large quantities in all areas walked. In areas low in other types of pottery, there are more significant Byzantine hotspots, for example, over at Limnionas and right down by the coast at Velenithia. The most represented functional group of all pottery is transport vessels, totaling 45% of the total assemblage, with tablewares next at 32%. Over half of our pottery is in an abraded and worn condition. A little over 10% is well preserved, while a small but significant 3% is burnt and sooty. A little over half of our pottery sherds are from amphoras, both transport and tablewares. Jugs, bowls, plates characterize most of our cooking and household wares, while we also have a small number of cups, kilikas and skiffoi, most of them originating from Vel 1, which again, I will visit specifically in just a second. Early analysis of the fabrics include a mixture of South Ionian sand fabrics, North Ionian lime fabrics, a local cooking and stony fabric, and a lime fabric represented only in our Byzantine ceramics. So the lion's share of our archaic and classical pottery comes from Velenithia, including the AOI that we call Vel 2 up towards the north end of Velenithia on the terraces. This is an area where we have large and well-preserved sherds, most of them actually eroding out of the side of the terraces. 147 sherds were collected for study from this area, of which 12 diagnostics are archaic, 14 classical, and 4 could date in either period. 57 sherds of the diagnostics in the Vel 2 group were undateable. The archaic sherds are transport amphoras, many of them manufactured in South Ionia as type 1 Samian-Milesian amphoras, but with an example of a Clazomenian amphora from North Ionia too. Black painted Attic fine wares dated between the 7th and 4th centuries BC also came from Vel 2. The classical period assemblage was similar in composition, principally of local South Ionian amphoras, including examples of the mushroom rim type. A great number of the South Ionian amphoras are made from what appears to be an incredibly local fabric for the southwest of the island, which could be indicative of the production of amphoras around this area to export goods of the like of olive oil and wine, as discussed earlier. And those few but positive indicators of imported amphoras give us a clue about the extent of the networks to which packaged products here might have been distributed and ships returning. Vel 1 is fairly different. This AOI is a hilltop located at one of the most northerly areas walked in 2022. The peak of the hill is covered in dense maquis, and most of the material we collected was eroding out of this area. The pottery here was fairly different to anything else we saw on the survey. Of 79 diagnostic sherds, all but 18 were small, fine, well-preserved tableware fragments, mainly from small cups or jugs. There was a mixture here of Attic fine glazed ware and local Ionian banded ware. All pieces found here could be dated to the Archaic period, with 14 that could date possibly a bit later between the 7th and 4th centuries BC. In addition to this fine tableware pottery, we found on this surface a blue scarab perforated at both ends. Again, kudos goes to eagle-eyed team member Katerina Ajarecki for this find. There are similarities, but not direct parallels of this piece with the Heraean. Interpretation of these sites is ongoing, but clearly Vel 2 and Vel 1, although they might be largely contemporary with one another, they're doing very different work, and the functions and activities of these two sites remain fairly distinct. Looking more broadly across the Archaic and Classical pottery from the whole survey region, there is evidence that West Samos is plugging itself into local and supra-regional networks. We have amphora types originating not only within Ionia, Chios, Klatsomeni, Ephesos, but also further afield in the Aegean at Kos, Rhodes, and as mentioned earlier, some pieces from Attica too. As we move down through time, these networks extend further to North Africa, Cilicia, and to Italy too. To put this more plainly, in the Archaic period, our networks are incredibly local, regional, with some interaction with other areas of Ionia. In the Classical period, this opens up, and further through time, particularly from the Hellenistic period onwards, this opens up at a much broader Mediterranean scale. The general condition of our ceramics is for large, fairly well-preserved sherds, but of even amphoras, including handles and toes, the sherds from the west of Velinidia are much smaller, more worn, and subject to different taphonomic and environmental conditions. There is, for instance, evidence for an old swamp area in this region, but work on environmental reconstruction of West Samos is ongoing. We're only halfway through the life of this project, and the results as we have them so far are only preliminary, in fact, only a few months old. So I do not want to go further today in advancing substantive conclusions as they emerge from the data set. Instead, I would like to think a little bit more about the physical landscape of Samos more broadly, and to consider how our target areas around Marithocampos and Karlovacy fit into a broader picture concerning physical connectivity more broadly, on how the insularity of Samos may or may not have some influence on material patterning that we'll see between the southwest and the northwest. So in September 2023 this year, we will be field walking in the northwest of the island, aiming to cover a comparative sample to the southwest, around 3 kilometers squared. One of our aims is to compare and contrast the northwest and the southwest of the island to one another to think about internal networking. This is both in terms of their AOI patterning and density, but also for the dating and functional groups of the material culture of each area. I'll use the rest of my paper today to suggest that there is low potential for physical connectivity directly between Northwest and Southwest Samos, given in particular what we know about island travel technologies of the Archaic and Classical periods. That there are low levels of physical connection between the two sides of the island constitutes some sort of hypothesis or model that we will be able to test against data that we collect and analyze in this summer and going forwards. Whether or not this hypothesis based only looking at physical connectivity is met with a positive or a negative result in the material culture will be interesting either way, providing substantive historical evidence for or against environmentally determined connectivity on Samos. So the basins of Marithocampos and Karlovacy are located between two mountains, Kirkis to the west and Karvounis to the east. Kirkis is the second highest mountain of the Aegean Islands, with its peak at 1,434 meters. Although its lower slopes have been variously terraced for olives throughout history, its upper layers are stark and rough marbles. The ominously named Cave of Pythagoras sits on the mountain's southeast slopes, supposedly the place where the famed philosopher hid himself from the tyrant Polykrates. To the east, Karvounis sits lower with a peak at 1,153 meters, predominantly schist with marble veins. The mountain was called locally Ampelos at one time in honor of the vines growing up its slopes. A more gentle ridge rises up above Marithocampos, running east-west between the two mountains, notably preventing visual communication of one side of the island to the other. And of the island neighbors, beyond either to the north or the south. Both sides of the island, though, maintain visual contact with the islands of Icaria and Fourni to the west. A simple GIS analysis of salient topographic data indicates dangerously high slope values for large sections of the island here, where a slope value of greater than 10% covers such a large part of this area is usually indicative of dangerous and often fatal terrain. In fact, there are very few natural communication channels between the northwest and the southwest of the island that would facilitate movement between these two basins. There is one route which runs past Castañar and Leca to the west today, or one further over to the east on the trail of modern-day Platanos, on the Platanos-Karlovacy road. If we want to connect the two sides of the island, the most usual way that we might do this in an insular environment is with sea travel, with circumnavigation. Particularly if we wanted to move quantities of stuff around, loading things onto boats is the most logical solution. This could be amphoras loaded with olive oil or wine, like the archaic South Ionian or classical mushroom amphoras, sherds from which we have found in the south. Perhaps even heavier freight like stone or timber. There is a quarry on the northwest of the island which is known to have been exploited in antiquity. Potami, located in the mountainous terrain of the lower slopes of Mount Kirkis, approximately 5 kilometers west of the Karlovacy harbour, and 1 kilometer as the crow flies from the north coast. 19th century travellers to this area report seeing unfinished columns at the quarry site, but this was not verified during the extensive work of Graham Shipley in the 1980s. And of course, the ancient authors tell us that Samos of the first millennium was used for exporting timber necessary for shipbuilding. So in connecting the northwest and southwest basin, what are the possibilities for moving cargoes like these, cargoes of amphoras, cargoes of stone, cargoes of timber, or mixed cargoes of both, mixed cargoes being a central idea of my monograph, that different types of economic network piggyback off one another. This question does, of course, presuppose that people on one side of the island wanted to use things that came from the other side, something that is much more difficult to verify given the limitations on historical data here. I'm limiting myself in this paper today to talking about archaic and classical periods, because the technologies for transport, both on sea and then on land, are fairly similar enough to one another down from the 7th through 5th centuries that they can usefully be taken together. By the late classical and Hellenistic period, we would be talking about much bigger ships, capable of charting much different types of routes or offering potential for different types of connectivity. So I want to stop my story there today. We know that in the Archaic period, even though it was primarily a warship, a 50-oared pentaconta could be used for transporting heavy cargo. Such a ship is probably similar in scale and order to the 6th century Pabuch-Bernu shipwreck found off the coast of Bodrum, and is thought to have sunk in the first half of the 6th century BC. Although the remains of this shipwreck itself are fairly fragmentary, enough of the hull has survived to indicate a complete length of 10 to 12 meters and a carrying capacity of around 200 amphoras, around 6 tons. The ship is thought to have operated in a small regional area off southwest Anatolia, needing to dock frequently in difficult sailing conditions. Of the classical period, even though the construction of much bigger ships did begin, of which we know, regarding the trireme, for example, of which we know that Samos had a fleet, requiring 170 oarsmen across 3 rows, and therefore taking 3 times as much person power as a Penteconda. Much smaller, lighter, and quicker merchant ships were likely used for this sort of haulage, for the sort of haulage that we're talking about here. The Chironeer shipwreck, or the Porticello shipwrecks, each have estimated carrying capacities of between 25 to 30 tons, at only a small degree greater than the Penteconda. In essence, what we're talking about here is small, light ships for circumnavigating West Samos. The problem is that light ships do not fare well here. We do not have primary evidence from antiquity, but there are nice comparative accounts. Early modern travel accounts tell us that Kolovasi had good links north with Chios and Smyrna, but the city was so exposed to the north wind that merchants had to load all ships offshore. The problem is not with Kolovasi per se, as there were good links that could take one here north and east. More of an issue in this sort of weather is going west and south, circumnavigating West Samos. It is a frequent pattern in the travel accounts that merchants loaded up small cargo ships with wine or onions at Kolovasi, but already had to abandon their ship and lose their cargo by the time they reached Megalo Setani, the beach ominously named after Great Satan, because the weather was just too bad. A particularly vivid account comes from Joseph Piton de Tournefort's Voyage into the Levant, published 1717. We went back that day to Kolovasi and embarked for Nicaria the next day, being February the 6th, but the southwest wind forced us into Port Satan. The north wind kept us at Satan until the 12th of February. We lodged in a cave where we burnt nothing day and night but laurels. We had about a very indifferent time of it. Our biscuit began to fall short, and the weather was unfit either for hunting or fishing. But what was still worse, we had drunk all the water we could find among the adjoining rocks. At length, the weather turned fair on the 13th. We lay hold of the opportunity to go to Patano, which is the famous island of Patmos. It's no surprise then that it is just off this coast to the west that an area of almost 60 shipwrecks has recently been discovered and is under investigation by Yorgos Koutsouplakis and his team. In a collaborative project between the Effort of Underwater Antiquities and the RPM Nautical Foundation between 2015 and 2018, this group of ships, the largest group of shipwrecks located in the Mediterranean, was discovered at this choke point between West Samos, Ikaria, and Fourni. 58 shipwrecks have been located around the Fourni archipelago to date, dating between the late Archaic period through the period of the Greek Revolution. Of the Archaic and classical shipwrecks, amphoras found on board originate locally in Ionia, from Samos, Miletus, Klaxomenae, and then also from Lesbos or from the North Aegean. This distribution is also notably similar to the pottery provenance of our 2022 survey pottery. In a recent publication of 2021, Peter Campbell and Yorgos Koutsouplakis have linked the predominance of shipwrecks around Ikaria to the environmental conditions in the East Aegean, that the location of the shipwrecks is indicative of ships sheltering from the strong northwest wind before progressing safely. Fourni, with its superior conditions for mooring a ship to Samos and Ikaria, attracts small ships requiring this sort of shelter. It's difficult directly to connect this evidence to our specific situation, but the general picture that emerges here is that there is low potential for physical connectivity in this area, taking a maritime route that relies too heavily on the rocky and dangerous coast of West Samos amidst adverse, particularly winter weather conditions. To note as well that this is not just a seasonal pattern. The summer wind on Samos, as in the rest of the Aegean, is the northwestern wind, the Meltemi. On Samos, this blows approximately 90% of the time in the summer, which, although providing predictable sailing conditions, sometimes makes conditions too strong to sail. Ellen Semple, in her Geography of the Mediterranean region, notes that in the summer months, sailing vessels for weeks at a time cannot beat against them, but have to tie up behind islands. This is something that we saw on Samos this past summer, when we saw a small private ship tied up in Ormos near where we were staying. Its captain was told us that they were unable to make the journey around the southern promontory of Samos owing to the strong winds. In his Reisen auf den griechischen Inseln of 1843, Ludwig Ross notes that the island of Samiapula, just off South Samos, is a useful temporary stopover point in waiting for the north wind to die down when going to Pythagoria in the summer. And he's not the only early modern author to note this too. Summer sailing might permit some sort of maritime connectivity between north and south, circumnavigating the island, but the days available for travel would have been few and unpredictably occurring. To put that another way, there is some potential for a connection here between northwest and southwest Samos, circumnavigated by boat, but perhaps there is not a very strong or reliable connection that can be made. What about then the potential for connecting north and south via land transport and the sorts of land transport that were available in the Archaic and Classical periods? What is the capacity that loads of transport amphoras or blocks of marble or timber from Potami could be taken down near Marithocampos? We know that there are some overland communication routes between the north and the south. Colleague Anastasia Vasiliou, in recent ethnographic interview work with residents from Samos, has been learning about how riverbeds seasonally are used today for moving between Marithocampos and Karlovy, and in earlier years on a donkey, this made the journey time around half a day. This is fine for moving people around or very small roads, but for bigger quantities of things, you need more robust infrastructure and proper roads and carts. It's generally understood that overland transport of heavy goods was possible in the Archaic and Classical period by taking loads using carts pulled by yokes of oxen. Hesiod, in his Works and Days, actually recommends 2 oxen. Bulls of 9 years, for their strength is unspent, and they are in the prime of their age. They are the best for work. And for both the Alephsis and Epidavros construction inscriptions, there is indication that moving freight around is something that requires oxen and carts. Oxen-drawn carts have been discussed qualitatively, at least for quite some time, going back to Steiner in the 1950s on the cost of building the Parthenon. But recent work from Anne Brisbane, Jari Pekkanen, and others has lent a quantitative dimension to these sorts of questions. They and others have estimated that, roughly speaking, a yoke of oxen on either a flat or slope road could transport between 200 and 1,000 kilograms at a time, working up to 8 hours a day. The speed for a yoke of oxen to move heavy freight on a 0 to 5% slope is usually around 1.5 kilometers an hour. For slopes greater than 10%, a half speed penalty of 0.75 kilometers per hour is suggested. And for 5 to 10% slopes, a midway value of around 1.125 kilometers an hour. Midsummer or late autumn provide the best times for moving heavy loads medium or long distances on any kind of roads, as both animals and seasonal workers might be available for work at this time. On Samos, vine, as one of the main crops of the island, would occupy time in the late summer, and early autumn would be required to prepare the vineyards before the rain. So the latest summer and early autumn might be the best time if one were to transport loads by these sorts of means. Roads would have also been too wet in winter and friction on road surfaces too low to undertake long and risky journeys. What I propose here is that one can use figures like these to model the possibility of ox-drawn transport on Archaic and Classical Samos to evaluate the capacity for land-based transport between the northwest and southwest basins. And I thank particularly here Anne Brisbane for productive conversations on this particular area and on modeling this kind of study. In the absence of data for the pre-modern road network, the in either archaeological or documentary terms, the layout of the contemporary road network has been taken in this part of the study as proxy for the archaic or classical road network. In fact, with Jana Mokrisheva, we have recently worked through a set of archival aerial photographs of this area. And the 1940s imagery, as far back as our data set would take us, this data set shows a road network with major routes qualitatively similar enough to today that one might suspect that there is some capacity for route persistence, in the words of Anya Slavish and Toby Wilkinson, in the most recent data set at least. And is perhaps not entirely beyond reason to assume continuity in the ways in which the terrain was traversed. Given the nature of the landscape of West Samos, first, the greater proportion of the land in West Samos is subject to a slope gradient of more than 10%, leaving practically very little alternative for where one can actually put roads. The modern road past Castagna and Lecca, or the Platanos-Karlovacy Highway, for instance, provide more or less the only navigable routes between the north and south basins. Similarly, the only safe route through the landscape is one that zigzags down steep slopes to slow the descent. Once a safe route has been located, roads might well be rebuilt and repaired through generations in preference to finding new routes. Modeling the transport of heavy freight builds on the past 20 years of work by landscape archaeologists adopting computational approaches to explore issues of distance, direction, and topography. Least cost and cost distance modeling in particular have been viewed as helpful tools for thinking through how and where resources might have been moved. The present analysis builds on this by beginning from the layout of the road network and applying topographic information laid over to produce a cost surface for only parts of the landscape covered by roads, i.e. those areas deemed passable. To put this another way, a model has been built here that considers both distance from a point and topography away from a point to see how much effort would be required to go from a given starting point to somewhere else along the landscape. Whereas cost rasters model the scenario of going from one point to every other point, here the model has been restricted to looking at only areas covered by a road. So the native cost raster calculator and modules within ArcGIS have been used to generate a cost distance raster going from Potami, the point of the possible archaic classical quarry, combining topographic and distance data of the traced roads. And thank you here to both to team members Alexandra Cataverni and Charles Hodgson for their assistance in digitizing the road data. So this calculation models the effect of both traveling further and traveling on more difficult terrain in how that affects the overall quality of the journey. Output raster units are arbitrary and range between 0 to 3 million. But this gives a map which shows how difficult it is to get anywhere on West Samos from a given start point, here Potami. To make that specific to our north-south connectivity case study, a simple least cost calculation indicated the most efficient route to take along the road network between Potami and Velenithia. And then using the slope raster, the length of segments with slope values 0 to 5%, 5 to 10, and over 10% has been here calculated. As discussed above, the speed for a yoke of oxen to move heavy freight on a 0 to 5% slope was taken as 1.5 kilometers an hour. Although the detail for which road was traveled cannot precisely be given at this zoomed out macro scale of the entire landscape, thinking about the character of roads is still crucial for reconstructing the general shape of journeys made and possible routes through the landscape. Dividing each journey segment by speed, a time in hours can be estimated for each slope, and therefore a total for the whole journey between Potami and Velenithia. Dividing this figure by an estimated 8 oxen hours of work per day, these values have been converted to a number of days required between this particular pair of points. This can be refined further by adding an additional hour, a conservative estimate at the start and end of each journey for loading and unloading time, and a further hour at the beginning and end of every day or multi-day journey for setup and dismantle time of the cart. Adding all those figures together, most simply, this model would suggest that if you were fully loaded up with cargo, and if you were using archaic and classical transport technologies to try and move heavy loads, it would take about 2.5 days to get between these points on the northwest and southwest of the island. This model suggests then that it takes this given time to move heavy quantities of goods from Patami to Velinidia. But is this plausible for archaic or classical lifeways? In an absence of direct evidence indicating maximum acceptable travel times, only general arguments can be made, and it might seem that transport time, although as in the case of circumnavigation, is perfectly fine for making connectivity possible, the time factor is something to consider in thinking about how long it is feasible for regular connection between Patami and Velinidia. The basis for this assumption is workforce availability. It's been stated above that the seasonal window within the year for moving heavy loads like batches of amphora or stone might be around 60 days, given labor and animal availability and the conditions of the roads too. At 2.5 days travel, with the same time required for returning the animals back to Patami, this would imply that a yoke of oxen in a season could only move around 8 fully weighted loads between Patami and Velinidia. A significant number of oxen would have been required, therefore, to move larger quantities in any one season. And it's not even clear whether these oxen would have been available themselves on Samos, particularly in the west. With vine and olive as the major cultivated crops on the island, there would be little need for large teams of oxen to have existed the rest of the year to plough the land anyway. This is possibly the stronger version of the argument here, that there wasn't so much infrastructure available than purely relying on the argument of time. 2.5 days journey time might seem a long time to us, but perhaps this was not so much of an issue if that's just how long it takes to get things done. The journey between Patami to Velinidia was possible by road or for moving things in small quantities, or if the material was specifically desired, as was indeed more direct and less paved roads along the river channels could be used. But on a routine basis, it simply takes too long to get from one side of the island to the other by these means to justify this as an efficient use of deploying resource. So after drawing 2 blanks, what can we say more positively about the potential for connection on West Samos? Let's cast the net a bit wider. I've already discussed that there is early indication of connections of West Samos with regional and super-regional networks within South Ionia, connecting to Miletus in the Meander Valley, with North Ionia to Klatsomeni and Chios, and further afield to Rhodes and Kos. Material culture suggests either direct or indirect connection with these neighbors, that ships were moving either directly from these places to West Samos, or that they or other ships were going by some intermediate point, moving cargo between different islands. As a parenthesis, there is also here an interesting positive result for a much larger issue, namely that neither the extent nor the intensity of the networks of West Samos appear to alter substantively between the Archaic and the Classical periods. In fact, their reach appears to grow somewhat. In spite of turbulent historical events taking place across the island, the rise and tyranny of Polykrates, the Athenian wars and occupation, material networks of West Samos appear to have been largely unaffected. Wider political networks do not appear to have had a detectable effect on the specific regional economic networks in this part of the island. This is only very preliminary thinking, and we need to drill more into the data to look, and also to look at a larger sample of data as we collect and process more ceramics. But this is certainly an interesting positive result for those of us who have worried a bit that there is little indirect interplay of the worlds of politics and economics in this part of the Aegean during these particular centuries. There is another perhaps more solid evidence for inter-island networking. Much detailed work on the quarries of Samos and on the provenance of the stones of the Heraean has indicated that the stone was brought from across major quarries on the island at Agiades, at Aspros Kavos, Kallithea, Kataruga, and Manolates. There is also some suggestion in Higgins' geological companion of marble from Potami being used in the Harayan. And in addition, as noted by Perslau Bindokat in the 1980s, described further by Kienast in the 1990s, and confirmed with petrographic analysis and isotopic work by Kramer, published in his PhD of 2004, there are a number of stones at the Harayan that originate from the neighboring island of Forni. Such blocks were also used in the Temple of Athena at Priena. The most part of this marble is probably from the largest quarry of Forni at Petrocopio. What does this mean for us and our inter-island connection? The scenario of moving all heavy marble blocks around also necessitates that ships carrying the marble heavy freight from Forni to the Harayan, or docking near the Milesian Peninsula of Priena, would have been circulating in this area. This is a route that would pass by West Samos by the southwest basin of Marithocampos. Surely positive evidence of traffic moving in and around this area. Even though we don't have such direct evidence of ships stopping at these places, we do have indirect evidence of this kind of route fragmentation, that ships, for example, originating from Chios or Kos or elsewhere, could have used these channels, taking mixed freight cargo and passing by West Samos en route. Even if there was not good potential for direct connection between northwest and the southwest basins of West Samos, there is some potential perhaps for linking these two areas by longer journeys that go separately to the northwest or southwest, but which have a common point of origin or destination, an intermediary connecting node. It's not Karlovacy to Marithocampos, but Karlovacy to Forni to Marithocampos, for example. It's not northwest Samos to southwest Samos, but for example, northwest to southwest Samos via somewhere else in between. This is still at the level of a theory and just a model, a hypothesis that needs testing, much more rigorous testing with more data. But once we have more data from this summer's field season and from other comparative areas, it will be productive to see how this sort of hypothesis plays out. There is, of course, precedent for short range and inter-island connectivity in this area. The most familiar comes in the form of the Pariah of Samos. From as early as the start of the 7th century BC, Samos had control of part of the Anatolian mainland between Priena and Anaia. A medium-sized area of the alluvial plain increased the arable land potential for Samian territory, with documentation that wheat was cultivated in this area. There would have also been a plentiful supply of timber here, perfect for enhancing Samos's shipbuilding and maritime activity. Graham Shipley has noted that possession of this area not only allowed for changes in the balance of the local economy, but it also gave greater scope for specialization by the polis. Strabo indicates too that a similar strategy was used by the Samians in the Roman period, using territory on what he claims had been totally otherwise abandoned Icaria off the coast of West Samos for additional territory and cultivation. A set of 7 late Hellenistic and early Roman inscriptions from the ancient territory of Oina confirmed the presence of Samians on Icaria. And Matthew Evans of Warwick University, who successfully defended his thesis on Friday, Matthew Evans and I have recently been working on a piece that suggests this sort of connection was short range, frequent inter-island mobility, rather than any sort of permanent settlement by the Samians on Icaria. I mentioned these 2 examples of off-island territory, not because I want to connect them directly with our material from Southwest Samos here, nor do I suggest building a hypothesis that takes Southwest Samos in with these same areas. Rather, I note these merely as examples of off-island networking, that in writing a story about the various component parts of West Samos, a much broader view of its neighbors on both other islands and on surrounding mainlands is going to be required to give the fullest picture. And this is more or less where I wanted to get to today. Reporting on a project still during the middle of its field activities, I did not want to come with substantive conclusions nor a new history for this part of the island in the Archaic and Classical period. Rather, my intention was to present to you some of our data, the spatial and material patterns that are already emerging, from a full season of field walking at Southwest Samos, and to think with some wider theoretical and regional frameworks in which our project is situated, more of a case of showing our working on some current theories, models, and hypotheses as we go into another season of field walking this September. From the 2022 material, we have positive indicators from the Bronze Age through Byzantine in this part of the island, with the most abundant material coming from the Byzantine and the older sites located inland and on higher terrain. The Archaic and Classical material is concentrated around the model settlement of Velenithia, with two distinct areas to the patterning. A lower area of transport amphoras eroding from agricultural terracing, well-preserved pieces indicative of local South Ionian and regional networks, and an area higher up the hill of fine pottery, including Attic and Ionian banded wares. I've wondered about the degree of connection that we will or will not see in the spatial patterns and material culture when we progress to an equivalent sample in the northwest side of the island this summer. I've suggested that the landscape and geography of West Samos provide a particularly challenging scenario regarding physical connectivity for regular and predictable movement between these two sides of the island in light of archaic and classical transport technologies. This has been a methodological experiment in an archaeology and history of moving things around to think with how that links into wider settlement and distribution patterns of the landscape. I've suggested that in building hypotheses about the connectivity of this island, we need to think variously on the connecting and isolating potential of both the land and the sea. I've suggested that the wider regional evidence gives us useful tools for thinking about how and where West Samos might connect itself, particularly in light of route ships and sailing patterns that must have been operating in this area. Even if Northwest and Southwest Samos appear in geographic terms to offer low potential for direct connection, the role of intermediary nodes, both from the Anatolian mainland and from neighboring islands, is a model that is well worth considering as we grow our data set. I began this evening by talking about resources, about organization of the landscape of Samos, about its economic interactions with neighbors. Such is the motivation for thinking about insular connectivity here, not just to think about networking in abstract terms, but to consider how connection enabled the sorts of activities that our literary sources tell us took place connecting this island. We've come to this area in some senses as a blank spot, and it's only through this further work and analysis of new data that we can continue to shed light on these issues. Thank you very much to you, and thank you to everyone who has contributed to this project so far.